Here we are looking for a valid conclusion. Again, not looking for a truth value here. It's not true or false. It's valid or invalid. And then looking for that conclusion. So here, all children have pets. It doesn't feel like it, but we've got an if-then statement. If child, then pet. All right. So that is our conditional statement. We're not arguing whether that's true or false. That is our conditional statement. All right. So that means if Laura were a child, then she should have a pet. So Laura does not have a pet. So that means that she is not in the pet world. Let's see. Let me draw a Venn diagram here, actually. This is the world of people that have pets. And this is the world of people that are children, right there. So all children have a pet. So people that are not children can have pets, but everybody who is a child does have a pet. So Laura does not have a pet, so she's out here. And because Laura does not have a pet, that means that she cannot be a child. So I'm going to throw up dot, dot, dot. Remember those triangle dots mean therefore. You can also just write the word therefore. Therefore, Laura is not a child. What we've got here is a negation to the conclusion, which means that we can negate the hypothesis. So Laura does not have a pet, so she's not a child, and that is the law of contrapositive. And it's contrapositive inverse, but if you just write law of contrapositive, I got you. That's all right. All right. Next up, if angles are supplementary, then they equal 180 degrees. So we've got an if-then statement. All right. If angles are a linear pair, then they are supplementary. Okay. I see a law of syllogism here, but you'll notice that it's kind of backwards. So let's call the linear pair P and the supplementary Q. And over here we've got Q and then element of P, Q, R. There we go. So we've got P then Q, Q then R. So now we can go straight to if linear pair, then equal 180 degrees. And again, that's the law of syllogism. All right. Then finally, we've got, not finally, I don't know why I said that, we got 3 left. If it is sunny, then I am outside. I am outside. Again, I think the easiest way to look at this is a Venn diagram. So, let's see. Here's the world of sunny. Here's the world where I'm outside. You can see that every time it's sunny, I am outside, but there are times where it's not sunny, then I'm outside. So being outside might be here, it might be here. I cannot draw a valid conclusion, so no valid conclusion. It's looking for me to make that mistake right there, that it's kind of that backwards law of detachment or a converse law, but there is no law for converse because converse and conditional do not share a truth value. 25. If you go to Thomas Jefferson Middle School, then you live in Arlington. All right. Andy goes to Thomas Jefferson Middle School, therefore he lives in Arlington. This is a straight up law of detachment. We've got P, then Q. P happens, so therefore Q must happen. So I'm going to throw up 3 dots for therefore. Andy lives in Arlington. And this is, I just said it, law of detachment. All right. And now finally, yes. All right. It is not cold. If it is cold, then it is snowing. So again, we've got some stuff shuffled around here. I want to make sure that I'm reading the right order. I like to start with that if-then statement. If it is cold, then it is snowing. All right, so I've got a P then Q. Again, if I think about this as a Venn diagram, I've got the world in which it is sorry. Got the world in which it is cold right there. And then since it's, if it is cold, then it is snowing. So we've got the world in which it is snowing out here. There we go. Ooh, sorry. Gotta give myself some brain somersaults there. So if it is cold, then it is snowing. So every time it's cold, it must be snowing. But we can see that if it is not cold, we might exist over there and it could still be snowing. So this is no valid conclusion.